All right, we're going to start the year off with 8M1, Module 1, Lesson 1, which is about exponential notation. I will cut over here to the notepad, and we are going to start this as quickly as possible. Let's get you going here. All right, so today what we're going to do is we're going to talk about exponential notation. And when I do this, I say 8M1L1. What that means is 8M1 module 1. This is module 1. And this is lesson 1. Okay, so this is right at the beginning of module 1, lesson 1, where we're learning about exponents and stuff. Okay, just wanted to get that little bit out of the way. Now, in exponential notation, we talk about, let's just talk a little bit about vocabulary. We're gonna start off with kind of like, and I'll just write this down so you can see it. We're gonna do a quick overview, and then we'll cut into examples. Lots of examples and explanations and, and procedures. And then we'll end with the homework help. So let's just pretend that you totally get exponential notation. You totally get the lesson. One thing you might want to do is just fast forward this YouTube and just go straight to homework help, where I'm going to go kind of cover some problems that are like the homework and just make sure you get it before you go there. Maybe you just want to have some examples. So maybe you just skip over the overview and you come straight here to the examples section so you can get a few more examples written down because you didn't copy down any examples in class today. Feel free to use this video however you like. All right, so let's get rid of this guy. We'll just box this guy off. We're going to just kind of switch colors and we're going to get going here. So let's talk about what is exponential notation. And I'm going to talk about what is a power. We're going to hit a little bit of vocabulary. What is a power expression? Now, power expressions, they look like this. Here's an example. Let's just write one down. 2 to the 4th. Now, this is, let's just talk about this little symbol here. This whole thing here is a power. The whole thing is a power. Okay? Now, this part in here, this 2, called your base. And this thing is called your exponent. Right? So 2 is the base, 4 is the exponent, and 2 to the 4th is the power. Right? So when your teacher talks about these various definitions in class, just make sure that you can understand, or you understand this is the vocabulary. All right. Now, let's talk about what does it mean. What does this mean? When I say 2 to the 4th, what that means is I repeat 2 times itself 4 times. So this simply says my base repeated 4 times. So this is my base, and I see, and I get, 4 times. So 2 to the 4th is equal to 2 times 2 times 2 times 2, which is equal to 16. So 2 to the 4th equals 16 is the value of this expression. These things are equivalent. Okay, so let's just do a few more of these. Let's take another example, and we'll go 4 to the 3rd power. So that's how we say this. We say we say 4 to the third power is one way of saying it. And that equals 4, the base, repeated 3 times, multiplied by itself 3 times. And that, if you multiply this out, 4 times 4 is 16, and 16 times 4 is 64. Okay, so let's do that one more time. Let's just do a couple more examples. And we'll make our background like this and go back over here. So we could say, you know, 3 to the 5th power. And maybe you can just write these down and make sure you understand it. Get a little piece of scratch paper and figure out what you think that is. But 3 to the 5th is 3 times 3 times 3 times 3 times 3. 3 multiplied 5 times. How about if I said, you know, 100 to the 2nd power? Give yourself a chance to try and do that. You can pause the video if you like, but the answer is 100 times 100. It's 100 repeated twice. How about this? Let's see if we get a little tricky here. How about 42 to the 1st power? Well, I write my base down, 42, and it's only multiplied 1 time, so I don't multiply it by anything else. So 42 to the 1st power is 42. In fact, anything to the 1st power is just itself. So let's move past these examples. Hopefully this is something you can understand. If this doesn't make sense to you, please leave me a message. I can try and explain it better on the YouTube comments. But we'll just move along. Now I want to make a quick analogy here, or draw a comparison, or help you understand some notation better. Let's look at something where we say, you know, let's just do a few more examples. So let's say this also works for fractions. So I could say, you know, 1/2, and I'll put it in parentheses to make it extremely clear, to the 3rd power. That we're talking about 1/2 to the 3rd power. So that would just be, let's see if you can figure it out. You can pause, think about it, but it's 1/2 times 1/2 times 1/2. And that, if we remember back to our 7th grade math, is 1/8. Right? You multiply your numerators and you multiply your denominators and you come up with your answer. So similarly, 2/3 to the 2nd is equal to your base, repeat the multiplication 2 times. And that equals 2 times 2 is my numerator, and my denominator, 3 times 3 is 9. Now, a couple points. I like to generally, you'll see me boxing my answers, and this is a good practice that will help your teachers. Teachers love it. When you boxing your answers is important. Some people like to circle them. I like to box them. It's but identifying, it's key because it commits to your answer. It says, this is what I know to be the answer. And B, it helps your teacher find the answer. Sometimes on a test, if you have a bunch of scribbles written down on a paper, the teacher doesn't know which answer is your answer if you haven't boxed it. So I'm going to encourage you to do this practice. I always encourage my students in class to follow that practice as well. Now, let's keep going forward, and let's create ourselves one more new sheet here. And we're going to look now at the fact that variables also work with powers. So just like 2 to the third equals 2 times 2 times 2, x to the third is equal to x times x times x. Now, notice I have switched from using x to a dot for multiplication. Right? And that's because sometimes an x can be confused with x, the variable. So I'm using dots instead, but they mean the same thing. I could have just as easily written this as 2 dot 2 dot 2, and that would be probably more consistent. So let's look at this and let's try seeing if you can figure out what is, y to the fifth. Pause the video. I'm going to tell you, pause and check. So I'm going to tell you now, hopefully you come back after pausing, and it's y times y times y times y times y. Commit to our answer. And there's our answer. Okay, so, and it could be, you can use any variables, right? You could use a to the second is equal to a times a. Or a, let's do another one. A to the 24th is equal to a times a times a times dot 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 times a. And we can say down here 24 a's. So that's a way where we can write an answer without having to, we don't have to write 24 a's, but we can make it clear that 24 a's is what you'd be multiplying if you wanted to say a to the 24th. Good. Now, another point. This is a key point. Key point. And this is on order of operations. So let's look at this. So if I say -2, and you'll see problems like this, so be careful. -2 to the fourth, and I'm going to show you another one, -2 in parentheses to the fourth. The question is does this what does this equal? What does that equal? Is that equal to -2 times -2 times -2 times -2? Or is that equal to -2 times 2 times 2 times 2? So in other words, do you take it to the fourth power first, or do you do the -2 first? And the answer is you raise this 2 to the fourth power first. So this is equal to this. The 4 and the 2 bind tightly. You can draw this little box, this little circle like this. And so our answer is going to be -16. And this is just the rules. This is just a rule that says what you do first. This is an arbitrary rule. Mathematicians just decided to make it this way. So over here, though, you have -2, the whole thing in parentheses times 4. So this, on the other hand, is equal to -2 to the 4th power. So that's -2 repeated 4 times multiplied. And this is equal to -2 times -2. Well, that is equal to 4 times -2 times -2. And that's equal to -8, because -4 times -2 is -8 times -2. And so that equals 16. So -2 to the 4th is not the same thing as -2 in parentheses to the 4th. So you got to be careful. I'll say that again, and we'll put it in another box. Say -2 to the 4th does not equal -2 to the 4th. Now I'm going to give you a teaser here, and I'm going to ask you a question, and I'm going to ask you, does -2 to the 3rd, does that equal question mark? Does that equal -2 to the 3rd? And I'll let you figure that one out, because it's not necessarily the same thing. So why don't you give that a go? You're going to have to figure this out on some homeworks and probably on some tests, but I'm not going to tell you the answer to that one. So now we're going to head into the last section of this video. And the last section of the video is going to focus on, we're going to focus on some examples. This is going to be called homework help. Okay. So the first one, and this is kind of also a review of the lesson. So question number 1 is rewrite using exponents. So rewrite this using exponents. What is 3 times 3 times 3 times 3? What does that equal? Question number 2 is rewrite here. Rewrite using exponents. X times x times x dot 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 times x if we had 50 x's, or or we repeated 50 times. Either way. And then the third thing is going to be ask this question: can you write an expression using -9 as a base? Sorry, oops, using -3 as a base to make 9. And then how about -9? Okay, why don't you give those a try, and then I'll come back and we'll cover the answers. Okay, so I assume you've paused and have come back. So if we write this using exponents, we write our base of 3, because that's the thing that's being repeated, multiplied. That's the thing that we're repeat multiplying, and we're repeat multiplying it 4 times. So our answer is 3 to the 4th, you know, box that answer. Teacher's going to love you when you box your answers. Now, if we have x times x times x times x times x, and we do that 50 times, our base is what? Our base is x, and we multiply it 50 times. There's your answer. Now let's see if we can make an expression that makes 9 using -3 as a base. Well, let's see what happens when we take -3 and we multiply it by -3. Well, that will equal 9. So in this case, yeah, we can make 9 using -3 as a base. We rewrite it like this. Now the question is, can we make -9? Well, the answer is no, because -3 times -3 is going to be, you know, that's going to be positive. But can we then make, let me just extend it further. Can we make -27? The answer is yes, because that would be -3 times -3 times -3. And that's -27. So it's interesting. -3 is a base. It's going to flip-flop. So -3 to the 1 is equal to -3. -3 to the 2 is +9. -3, I need to put these in parentheses. 3 equals -27. -3 to the 4th is +81. So notice that for positive exponents, numbers with negative bases will always be positive. But for odd numbers, they will be negative. Okay. We'll just let this sink in. Hopefully this was a useful exercise for you, or useful video for you. Let me know. Let me know if this was good. If you need extra examples. If I go too slow, feel free to just fast forward over the stuff that makes sense and just kind of watch. Watch for the key homework help. Watch for those extra examples. Watch for those procedures and just copy those down. I go slowly because some people out there need me to go more slowly. And the neat thing about videos that you cannot do in class, you can't fast forward the teacher in class, but in these videos, you can fast forward to the stuff you need and you can ignore the stuff you don't need. You can do this at your own pace. And hopefully these are useful. Let me know. Please comment on YouTube. The comments are very helpful to me. And we'll be seeing you next time on Dave Lipscomb Teaches Math. Oh, I love applause. I do this for you guys, and applause makes me feel great. We'll see you next time.